Let's talk about divisibility rules. I want to go over these with you. I know that it's written out for you, but these are pretty important. And if you'll get those out and just look at them a minute, the reason that I started the divisibility rules here is because you will use them a lot in making factor trees. And factor trees are going to be a large part of what you're going to do for the next week at least, okay? So when we look to see, oh man, what is this number, 488? What is it going to divide by? I don't know. I know what 16 divides by, but 488 or 288, I don't know. Well, what you can do is look at the divisibility rules. You can start with really small numbers to divide. And if your number ends in an even number, which means the whole number is even, if the number is even, it will always divide by 2. And so what I do with large numbers is I look to see if it's even. This is how I do it. So it should work for y'all. Are you guys okay? I'm hearing something in the background. Luannie, are you okay?
Yes, ma'am.
Okay. Okay. Your audio is strange.
Okay.
Oh, there you are. Okay. Okay. I was just worried about you. So if I come across a large number, even 1,068, okay, 1,068, that ends in an even number, so I know that I can divide it by 2. And starting with the small numbers is a great way to start. As long as your answer ends in an even number, you can divide by 2 again, divide by 2 again, divide by 2 again, until it's not an even number. When it's not, I suggest that you test to see if it's divided by 3. Now, this is kind of cool. If the sum of the digits in the number will divide by 3, then the whole thing will divide by 3. So let's test that. It says, let's test it with something that we know. We know that 27 divides by 3, right? Well, let's test the rule. The rule says if I add the 2 and the 7 in 27, that comes up 9, right? Okay, let me write it out. Sometimes writing it out is better. Okay, I'm going to talk about 27, and we know, I'm starting with a small number. We know 27 will divide by 3, but let's put a test to it. The divisibility test says if I take 2 plus 7, those are the digits. Those are called digits. If I add the 2 and the 7 together, that becomes 9. And yes, 9 will divide by 3. That tells us that 27 will divide by 3. Let's try this one. 189. Okay, we know that 189 is not an even number, okay? So it won't divide by 2. Let's try the 3 test. The 3 test says add these together. So 1 plus 8 is 9. 9 plus 9 is 18. So will 18 divide by 3? Tell me yes. 18 will divide by 3. So that tells us that 189 will divide by 3. If I can add up the digits and they divide by 3, then the big number will divide by 3. I'm going to write that out and let's try one more. Okay, I wrote that out for you. If we add the digits, each one of those numbers in a number are called digits. So let's try a large one. How about 2037? Okay. We know it's not even, so it won't divide by 2. Let's try the 3 test. If I take 2 plus 0 plus 3 plus 7, what do I get?
2 plus 0 plus 3 plus 7, 8, 9, 10, 11, 12. 12, is that
Okay.
right?
It equals 12. And the test that you do, will 12 divide by 3?
No.
Try again. Will 12 divide by 3?
Yes.
Yes.
3 times 4, right? 3 times 4 is 12.
Yeah.
Yes.
So if 12 will divide by 3, then 2037 will also divide by 3. That's a good test to help you decide on these large numbers. Do you kind of get the idea?
I think so.
You think so, you said?
Yeah, I said I think so.
Okay, so let's go to the test for division by 4. If a number is divisible by 4, you just look at the last 2 digits in the number. If the last 2 digits divide by 4, then the entire number will. So I'm going to go crazy here. 5, 7, 8, 2, 4. Okay, I want to find out if this is divisible by 4. All I do is look at the last 2 digits, 24, right?
Yes.
The last 2 digits. If that will divide by 4, then guess what? The entire number will divide by 4. That's how you can quickly look at a number and say, what will this divide by? If the last 2 digits of a number will divide by 4, then the entire number will divide by 4. Kind of crazy, huh?
Yes.
The rest of you are kind of quiet. You just drinking it in, are you?
Yeah. Yeah. I like how you kind of taught us like the 2 plus 0 plus 3 plus 7. I know that's going to be important somewhere along in here, isn't it?
Yes. Yes. Yeah. All of the lesson today and into next week, you'll be using these divisibility rules. Yeah. Now, like Brandy said, the 5 and the 10, you can tell if a number is divisible by 5, if it ends in 5 or 0. And it's on your paper. It says a number will divide by 5 if the number ends in a 5 or a 0. That one's easy. All you do is look at it. If it has a 5 or a 0 on the end, it will divide by 5.
Okay.
Then number 6, I usually don't use this one a lot, but you can tell if a number will divide by 6 if it passes the 3 test and the 2 test. Okay, so it has to be an even number and pass the 3 test for it to divide by 6. Usually we don't use that one because we've already divided by 2 or we've already divided by 3. So you usually don't have to use the 6 test, but I wanted you to see it. Okay? Then the last one here is probably the easiest of all of them.
It's the 10.
If the number ends in a 0, if there's a 0 at the end, it will divide by 10. If there's a 0 at the end, it'll divide by 10.
Okay.
Now, if a number doesn't divide by any of these, you can always try 7, 11, and 13. These are all prime numbers, but sometimes those will work in a number when none of these will. I don't use these too often either. So what you need to do is keep this divisibility rule handy, and also your prime number chart when you're working our problems today, especially the factor trees. Okay, keep this and your prime number chart handy. That will help you figure these problems out. How are we doing? Is there any question on that?
And on the where the prime numbers are down on the bottom of the divisibility rules,
Yes,
those are going to be the same as our prime number chart, right?
they will. Those are some common numbers that will divide into some of our big numbers if none of those others, like the 2, 3, 4, 5, and
Okay.
6. Okay.
Okay.
Those are some common ones that'll work when nothing else does.
Okay.
So since you have a calculator, it doesn't take long to try those.
Right.
Okay. All right. And you won't have to use those very often either. Now, the next page, page 2 in your packet, has to do with prime factor tree. Now, you guys have already been doing a factor tree because the prime factorization in the last package, they taught you a different way, but I taught you this way. So I think this one helps you keep, it helps you keep things straight. Okay. Now, the one thing that I'm a little concerned about this one is everything is circled, and I know why. It's because they want you to put a number in here. It's telling you to fill in the blanks. When we do a factor tree, we definitely circle the primes, but understand this circle isn't circling a prime. It's here just to tell you to fill in the blank. You see? So maybe on this particular page, look here, 16, it says it's going to break down or divide by 2 and 8.
8.
Okay? 8 isn't a prime. So it will break down to 2 and 4. 4 is not a prime either. So it breaks down divided by 2 and 2. So it probably wouldn't hurt for you guys to have a highlighter or a colored pencil or something, and definitely circle the primes when you get to primes so you don't get mixed up that this is a prime. This is not a prime. Does everybody understand what I'm telling you?
Yes.
The only reason it's here is to tell you to fill in the blanks. Okay, that's it.
Whoa.
Do you see?
Go for it. Yes.
Okay, anybody? Sherry, are you there?
Yes, ma'am.
Okay, I was just, are you okay with this also? You understand this?
Yes, ma'am.
And I would highly encourage you guys to have a different pen or a highlighter or something to practice circling only the primes. Okay, that's going to be very important. Okay. And page 3 is going to be the same thing. It looks like a little bit larger numbers, but you're going to do exactly the same thing here. Then they take away the circles, and you need to figure it out yourself on the next page. And we've already done some of these in the last package. So you should be okay here with the factor trees. You're going to start right here with 12 and find out what times what gives you 12. Now, again, I'm going to tell you, like I did in the last recording, that you can say 2 times 6, or you can start with 3 times 4. It doesn't matter which factors you start with first, because you're going to break down more and more the ones that are not prime. You're going to circle the primes. And by the time you get to the bottom, your list of prime numbers is going to equal and match everybody else's. Does not matter how you start. 2 and 6, 3 and 4, does not matter how you start. Understand?
Yes.
We're okay with factor trees?
Yeah.
Because I guarantee my silly story deals with factor trees. Okay, same thing. Next page. I gave you a lot of practice on factor trees, so you can practice your divisibility rules. You don't have to do every single one, but the more you do, the better you'll get at it. Now, this one, I want to add to the instructions. This one says, write each number in prime factor form. You're going to do a factor tree, yes. And like on number 72, look at the answer. It says 2 times 2 times 2 times 3 times 3. Okay, and that is prime factor form. I would like for you all to go one step further and put your factor form into exponential form. Looks like this. We've done this before, but I would like for you all to practice this. Notice that the 3 2s, 2 times 2 times 2, gives you 2 to the third. 3 times 3, there's only 2 of them, times
Yeah.
3 to the second power. I would like for you to continue this and practice your exponential form, okay? Are y'all okay with that?
Yes.
Okay, so we move on. Again, the next page is going to be the same thing. Lots of practice. Okay. Now, I want to talk to you about radicals.
Okay.
I looked at where I had to title this lesson, and I put on there radical operations, and I thought, that sounds kind of funny. It sounds like we're going into surgery, right? Radical operations. A radical is simply this symbol right here, a radical.
Yeah.
Now, in this little v in here, you're going to see numbers from time to time. Right now, I want you to put in your notes somewhere or in your brain somewhere. If there is not a number in there at all, it's an invisible 2. Oh, good heavens. Now 2 is invisible, okay? But it's an invisible 2. This represents a root. I'm going to explain a root here in a minute. I'm going to put the invisible 2 in here right now. Now, up until now, we said, for instance, 5 times 5 equals 25. We said 5 squared equals 25. Okay. Up until now, we know that 5 times 5 equals 25, of course, right? And because we learned about exponents, we know we can write this 5 times 5 as 5 squared because it's 2 5s that are multiplied together. So 5 squared equals 25, yes?
Yes.
But what you're going to find out in mathematics, especially algebra, is every operation that you do in mathematics is going to have an undo or an opposite operation that's going to take you back to the original. And this one, a squared
Is it?
and a square root are opposite operations. Now get that in your head. Because when we solve equations the way we've been doing it, we said if we have a plus and we want to undo a plus, we subtract, right? Because
Yes.
add and subtract are opposite operations, right?
Right.
And if we want to undo multiplication, we use division because they're opposite operations, right?
Right.
I want you to understand that if I want to undo a squared, the opposite operation is to square root it. Now we'll show you how that works. If 5 squared equals 25, then the square root of 25, when we want the square root of 25, that means we're looking for a number when taken times itself will give me 25. So it can't be 7. 7 times 7 won't give me 25. 3 times 3 won't give me 25, but 5 times 5 will. So when I'm looking for the square root of 25, I want to know what number times itself will give me this answer. So I'm undoing a squared. The answer is 5. Because 5 times 5 will give me 25. 5 times 5 will give me 25. So tell me without using your calculator, what would be the square root of 81? I need a number.
9.
Good. A number times itself, not a number times 3 or a number times 7, but a number times itself that will give me 81. So it's going to be 9 in this case, because the opposite way of writing this is 9 squared gives me 81. So the square root of 81 gives me 9. Do you see how it works backwards and forwards?
Yes.
Okay. Now let's move to cubed root. Cubed root, these are the most common, okay? These two. Now, if you have the cubed root of something, it's going to look like this, and its root here will not be invisible. It'll be written down in the V, as close to the V as possible. This says a cubed root. That means that I need something times itself that will give me the number inside. Okay, so let's try the cubed root of 8. Now your calculator will do this, but I want you to understand what's happening. The cubed root of 8, that means I'm going to need something smaller, and it needs to be multiplied by itself 3 times. The answer here, I'll go ahead and tell you, is 2. The answer to this is 2. This is how it's written. Because I can take, let me find my fingers, 2 times 2 is 4, times 2, the third time, is 8. 2 times 2 times 2. It has to be times itself. Yes, the calculator will do this for you. But I'm going to show you how we're going to do this. Everybody okay?
Mhm.
Sort of. Brandy, you're chewing your fingernails.
And let me see that answer again, or your thing. Okay.
Cubed root.
Yeah.
It'll get easier, Brandy. I'm going to show you.
Okay. Okay.
You're not supposed to use your calculator, you little booger. Press enter and show them.
I did. It's a 2.
Okay, leave it. Let everybody look at it. cubed root of 8. Okay, let's go ahead and show everybody how to do that.
You said about the calculator, so I figured I'd put in the calculator.
Yes. I just don't know what I'm going to do with you. All right. Some calculators have a cubed root. This one doesn't. It has what we call an anything root. I want you to look really close where this fingernail is, right here. See the carrot top? Right above the carrot top
Yeah.
is an X root. See it? I call this the anything root. Down here is a square root if you want to use that. You can use this all the time if you want. It's called the anything root. That's what I call it. And if you want to find the cubed root, you will use this button. But since this is written in green, before you push this button, you have to use the green button to find the cubed root. Okay, we're going to use the calculator to find the cubed root of 8. Okay. Now, the way this works, if you notice, this is an anything. Sorry. This is called an anything root. So the calculator can't read your mind. You're going to have to tell it first what root you want. We want the cubed root, so we put a 3 in first. Okay, it doesn't show on the screen, but I have told, well, I guess if I turned it on. Okay, turning it on is the first step to success. Okay. Okay, now we're going to say we want the cubed root. Okay, it just puts a 3 on there, but now we're going to tell it that 3 that I put in there, I want it to be a root. So because this is in green, we're going to have to push the green button first, and then the anything root, which is this carrot top button. Now look what it looks like.
Yeah.
See, it put it as a root because I told it to, and it's saying cubed root of what? And I just simply put the 8 in like Rachel did a minute ago. And I'm not sure, but I think it's safe to scoot on over. You don't want anything else typed under the radical sign. So you scoot it over and then press your enter key. That gives you the answer of 2. Okay. Now the next thing I'm going to tell you is important, very, very important. Everything I tell you is important. But for right now, I'm not going to try to explain it, but I want you to know this. I'll explain it later on down the road. But to find the square root of a number. You okay, Brandy?
Yeah.
Allergies?
Yes.
Okay, if we're dealing with negatives, I'm going to do this. Okay, right here I'm talking about the square root of a negative number and the cubed root of a negative number. You cannot get a real answer, a real number answer to the square root of a negative number. It won't happen. Every time you try to do that on your calculator, you will get an error. You cannot find a real, remember when we talked about real numbers? And I told you there's some imaginary numbers too. We're not going to do imaginary numbers in here, but that's the only answer, an imaginary number that you could get out of this. No real answers. So finding the square root of a negative number is illegal. You can't do it. Okay? So when you forget that and you put it on your calculator and you get an error, that's what happened probably. You cannot get the square root of a negative number. Okay, everybody understand?
Yes.
Yes.
A cubed root of a negative number, however, works just fine. Okay, a cubed root you can take of a negative number. In fact,
Are the squares, are those only in twos?
I'm not sure what you ask.
On the first one that you showed us, that when dealing with the square negative to find the
Yes.
number, we can't, is the two always going to be, you can't find it? Because we're kind of, are we relating back to this one on that first one you did?
Yes.
Okay.
And those are all positive, so they're fine.
Okay.
I'll show you some examples, okay? Right off our worksheet. But I
Okay.
want to talk to you about this also. You know how I told you you can't get the square root of a negative number. In fact, you can't get any even root of a negative number. So if it's the fourth root of a negative number, no. Sixth root of a negative number, no. Eighth. If the root is even, you can't get that with a negative number, okay? Does everybody understand? Can't do these.
Okay.
However, a negative root is just fine if you have odd numbers, 3, 5, 7, 9, okay? Now this will be something that I guarantee you're going to forget, but when you forget it 2 or 3 times, then you'll start to remember, okay? Because your calculator will not let you do an even root of a negative number. Everybody understand? Do you need this some more?
No.
Are we good?
Mhm.
Now I want to show you the difference. You are going to find some numbers that have a negative, but the negative is on the outside. So what happens in this case is you deal with the radical like it was parentheses. And then when you have this answer, then you put a negative on the answer or multiply by -1. That's what you're doing. But you work the radical first. So if the radical doesn't have a negative inside, you're able to work it, get an answer, and then you multiply by your negative, which will put a negative on the answer. Confusing enough?
Yes.
If the negative is under the radical, it's not allowed with an even root. But if it's on the outside, this will work with anything. If it's on the outside. So let's do a couple of problems that I'm going to make up. So what's the square root of 36?
6.
Okay, good. Because,
Is it?
yes,
Oh,
because 6 times 6 will give you 36, right? Yes, you silly girl. So what is the square root of a negative 36?
It'd be a -6.
3.
What root is this? If there's not a number
Uh,
showing, what is it?
2. Invisible 2.
Yes, it's an invisible 2. And if we have an even root, what do we know about that?
We can't, so to be a 3.
No, you don't change the root. You tell me what the answer to this is. It's a square root of a negative. Can you find the square root of a negative?
Square root of a negative.
No,
Why?
because it's
Because
illegal.
Yes,
Because the root is,
negative.
no, the root in the little v. Because the root is a 2 and 2 is even.
Right.
If you have
Okay.
an even root, you cannot find the answer of a negative.
Okay.
An even root. Okay, let's do some more. It's okay.
Okay.
How about this? What root is this?
0.
No, what root?
5.
That means what's in the little v?
Oh, a 25.
The v in the little v. What root?
Oh, a negative.
That's gonna be I want to say 5. Is that right?
Okay, I don't want the answer. I'm asking, what is this number? Right there.
A 2.
2.
No.
Yes, it is. It's a square root.
Oh.
It's a 2. It's the invisible 2, right?
Yes.
Okay. So what is the square root of 25?
2.
Square root of 25. That means what times what? Will
5.
give- Good. And then I put the negative on my answer.
So it'd
Do
be
you-
a negative.
So negative 5. Because go ahead.
I'm sorry. Go ahead.
Because the answer to the square root of 25 is 5. Then the negative's on the outside, so we put the negative on the answer.
Okay.
Yes?
Yes.
Okay.
So how do you?
I know.
So how does she know it was a 2?
Because if there is not one written, if there is not a number written here in the V, right here,
Yes.
then it's an understood 2. It's an understood square root. And the
Okay.
reason for that is we use square root radicals so much that they decided not to put the 2 in there because everybody uses the square root. So let's just not even put a 2 in there. Okay, but cubed roots are used less often. So let's put the 3 in there, or a 4 or a 5. Let's look at these.
Okay, so if it's a different number, they'll put it. But if it's no number, it's a 2.
You're exactly right, Sherry.
Okay.
You're exactly right. Okay, let me see here. I'm looking at the next page and deciding to do this or not with you. Yeah, I think I want to show you my stupid story. You won't be able to do all the pages in the packet, but I'm going to finish with this. Okay, we are going to simplify radicals. simplify. And I mean the same as when we had fractions that weren't the lowest terms, then we had to simplify them and make them smaller and make them better. Y'all understand what I'm saying? Okay, so we're going to do the same thing with radicals. If I have, we're going to do this one right here, and then I'm going to tell you my stupid story. We're going to take the square root of 24, all right? I can't even remember what I was going to say. Okay, if something is bigger than like 10, Rachel, wake up. Rachel, wake up. I know you've got to sleep at night or you can't. You poor baby. Okay, I love you, you know.
I know.
Okay, stay awake. Stand up if you have to. Stand up if you have to. Okay, we're going to find the square root of 24. Now, if you put that in your calculator, you're going to find out that it is not what we call a perfect square. And I don't mind if you try that in your calculator real quick, but it will come out a decimal. Okay? We cannot find a perfect square for that, but we can simplify it. Now, there are two ways that teachers teach. Well, there's another way that teachers teach this. Okay? Let's see. This is the way a lot of teachers teach it. And if you want to do this, this is okay. They break down 24 and you would need to use your, sorry, I have a heater on, it's getting hot. There we go. Okay, good heavens. If you have your squares and your square root handout that I gave you, this will work for it. What you're looking for is a perfect square that can be divided out of this. So here is what you would do. You would say 24 is the same as 4 times 6. The reason I chose this is because I can find a square root of 4. That's called a perfect square, okay? So, so the way you would work this, most teachers teach this, after you have separated this, then you can make these two separate radicals. You can separate them. Okay. And after you separate them, you are able to find the square root of 4, which is 2. But you can't find a perfect square for 6. And so the simplified answer to the square root of 24 is going to be 2 square roots of 6. This is how they teach it in most math classrooms. Now, the reason that I chose to find a different way, and it's up to you which one you want to use. The reason I found a different way is because as it gets larger, I have to think, okay, perfect square, what would go in here? And it takes me a little bit longer to think it out. Now, it's perfectly fine, and a lot of people use this method. I'm going to show you a stupid story.
I love your stories.
Okay, everybody hold on to your britches. Here we go. I'm going to find the square root of 24. Now think of this radical as a house. And this is 24's house. Just like the house that I'm sitting in is Bond's house, Deborah Bond, okay? This is 24's house. Now, in this house, there are several teenagers. And it's going to be important for us to find out who the teenagers are. So what we're going to do to find out the teenagers is to do a prime factorization factor tree of 24. So what I'm going to do is start my factor tree. And because I'm not in front of the chalkboard, I'm going to do little pieces and show you and little pieces and show you, okay? But we're going to take 24 and make a prime factorization of that. So some of you might have divided by 2 first. I said 6 times 4 is 24, but neither one of those are primes. So I'm going to have to divide the 6 and I'm going to have to divide the 4.
Four, so 2, 2.
Hey, Mom.
And my prime factorization looks like this. Now, no matter how you started your factor tree, it will come down to 3 2s and a 3.
Down. Gotta be quiet.
Everybody
okay?
good?
Yeah,
Y'all have some background noise. Be sure and mute, okay?
already.
Yes, ma'am. Sorry.
That's okay. Just letting you know. Okay, now what in my silly story, in this house, 24's house, there are 4 teenagers, okay? The prime numbers I'm going to call teenagers, okay? Now, it is Saturday night, and teenagers like to go out and meet their friends and chill out on the parking lot downtown. I came from a small town. That was our big deal, is sit on the parking lot downtown. Okay, they want to go out of the house on Saturday night. And mom says, I really understand because I was a kid once and I understand that, but I want you to be safe. The times are different now. So if you can find a partner to go out with you, then you can go out of the house. Okay, everybody understand the story?
Yes.
You have to find a partner before you can go out of the house. So the teenagers start looking around, and one of the 2s says, ha ha ha, ha ha, I found a partner.
Yep.
So we get to go out of the house tonight. Nah, 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 nah. Well, when they go out of the house, when they move out of the house, they are no longer 2 people, but they are one group. They are a 2 group, and they go outside of the house. So do you see that the group, when they went outside the house, is a 2 group? It's not 2 people anymore. Everybody understand?
Yes.
Now, if they can't find a partner, somebody that looks the same as them, if they can't find a partner, they have to stay home tonight and try again next time. Well, this 2 right here says, dang it, I can't find one. And this 3 starts crying because he can't go out because there's not another 3 to match him, and there's not another 2 to match him. And so both of these guys have to stay inside. So I'm going to put the 2 inside and the 3 inside the house for another time. Do y'all understand what I'm doing so far?
Yes.
Now, if there are multiple things inside the house, we multiply them. If there are several things on the outside that we'll see later, then you multiply those. So my answer to simplifying the square root of 24 is 2 square roots of 6. Do y'all see that?
Yeah, I seen where you were going with it.
Is it confusing?
No.
I have to look at Brittany's face or Brandy's face. You're on mute, babe. Still not. There we go.
Okay, so the 6, because the 2 and the 3 didn't have a group, right?
Yes.
So, but the 6 would go into the house.
Yes, it has to stay there because what you do when you're placing people, when you're placing all your teenagers, that's this step right here. And you say,
Right.
here's a group, it goes outside, but all the leftovers have to stay inside. And then for your final answer, whatever's inside you multiply, whatever's outside you multiply, which gives you a final answer, which was the same as what we got here.
Okay.
We'll do another one. Okay.
Okay. Okay.
Okay. So let's do the square root of 45. We're going to simplify the square root of 45. Okay. Simplify the square root of 45, and we use the prime factorization, a factor tree. Okay.
Okay. So 5 would be a 1.
Remember to circle your primes because that will tell you who the teenagers are. And some of these get a lot of teenagers in the house. Okay. Did everybody get this for your prime factorization?
Mm-hmm.
Yeah.
So now it's Saturday night. Let's find out who gets to go out and who has to stay home. Remember, we must be safe. So do you see that 3 can find a partner?
Yes.
It was 2 people, but when they get ready to go out,
Would be
they have to stay together. They're a 1 3 group. Do y'all see? And they get to go out. Now there's another teenager that's looking around for somebody to go out with, but he can't find any other sister or brother to go out with. So the 5 has to stay home tonight. And so your simplified form of the square root of 45 is 3 square roots of 5. Is it making any sense?
Mm-hmm.
Okay. Now, there are overprotective mothers.
So what do we do with that 9?
Put it on top.
The 9 isn't a teenager.
So we just forget about the 9?
Yes, because the 9 became the 3 times 3. So
Oh,
it,
yeah, that's right.
it doesn't
Okay.
exist anymore.
Okay.
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 All right. So now let's talk about overprotective mothers. How about we find the cubed root of 32? Now it's the cubed root. But watch what happens. We're still going to do a factor tree the exact same way. So let's do that first. Circle all your primes.
So 32.
Is everybody about there? By the time you're finished, you should have 5 twos, 5 teenagers, and all of them are twos. Now, this mother understands that the kids want to go out also. She's a little overprotective. So she says, yes, you can go out. I want you to be safe, but you must go out in sets of 3, not 2. Do you understand this right here? The root tells how many has to be in a group. She's a little overprotective, and she said there has to be 3 of you before you can go out. So these 3 get together immediately and they say, woohoo, we get to go out because there's 3 of us to look out for each other. Now, when these 3 create a group and go out, they're only 1 2 group. So this group of 3 goes out as a 1 2 group. Because mom said you have to have 3 in a group before you can go out. So they found 3 and went out as a group. Only 1 group. Then there are 2 more teenagers, but they said, nah, mom said there has to be 3. Well, there's not 3 more 2s. So the teenagers that are left have to stay home. And so your final answer is when you multiply everything from the outside, multiply everything on the inside, and give a final answer.
64.
So we have 2 cubed roots of 4. Do y'all see it?
Yeah.
The root house has to be there. Don't forget to put that little 3 up there. You multiply the 2 teenagers that are inside. We know that there's 1 group of 2s that got to go out. Is this making any sense to you?
Yes.
Little bit? Luannie? You're still not feeling well, are you? You're on mute. I can't hear you.
You
Yeah.
hear me?
I can now,
Oh, okay. Yeah, I'm still not feeling good.
but you're still going into work today?
Yeah, I'm right here looking at you on my break.
Take care of yourself, please.
Yes, ma'am.
Okay, and keep me posted.
Yes, ma'am.
Sherry, how are you with this?
I'm getting it
Okay.
slowly.
Brandy, I saw you kind of, yeah, I think.
It's I like the way we're doing the factor tree because it helps break it down where I can understand it better. But I think I still don't quite understand the little this what's it called? The root, the square root, like the
Uh-huh.
3.
Hmm.
I'm still a little confused with that.
The cubed root?
Yeah.
Of 3.
Okay, not simplifying, but just what it is.
Yeah, like because it only says that I can. What if it doesn't have it and we have to find the entire answer, or will it never do that?
What do you mean the entire answer?
Let me see.
Oh, I think I know what you're saying. See, the last one that we did where we got the 2 cubed roots of 4, that problem we
Yeah.
just did, that is the final answer in radical form.
In radical, okay.
If you needed a different form, you would simply put the cubed root of 32 in your calculator and get a decimal answer. That's another
Okay.
way to have an answer.
Okay.
Okay, but what we got is the final simplified answer. It is an answer.
And everything that's in the doghouse has to be multiplied.
Yes, if there's several things in there, they have to be multiplied.
Okay.
Let's do one where there's several things on the outside. Okay,
Okay.
okay, let's do the square root of 72. This is the mom that says you only have to have groups of 2 to go out. So what we're going to do is the square root of 72. So do your factor tree, okay? And we should come up with the same teenagers when we're done, okay? Okay, again, mute the background noise, please. Mute, guys. I'm hearing somebody's in trouble for being on the phone. Okay, this is the prime factorization that I'm getting for the square root of 72. I have 3 2s and 2 3s. Are all of you here?
You
Or
said
am I
three
going-
2s and 2 3s.
Yes.
That's what I have.
It doesn't matter how you started. You should end up with 3 2s and 2 3s that are circled. Those are your primes. And in this case, they're your teenagers. Now look up at the root right here. The root is an invisible 2. So this mom says groups of 2 are okay. Groups of 2 are okay. So the 3s look at each other and go, whoa, ho, 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 look at us. So we get to go out. There's one group of 3s. Don't put 2 of them out there. When the 3s go out, there's only one group. Yes? But if you look down there, the 2s have also found a group. They found a partner. And they get to go out front. Do you see? And then there's the leftover 2 that has to stay home. So right now you have this, but your answer is not 23 square roots of 2. If there's multiple things on the outside, you multiply those. And so our final simplified answer is 6 square roots of 2. Do y'all understand what we did there? I told everybody to mute. I'm sorry. Okay. So here's what I want you to do over the weekend. Here's what I would like for you to do. I'm going to give you several radicals to simplify instead of using the big ones on the page. We'll talk more about those next week. So let me see. The first 9 pages in the worksheet packet I want you to work on those, the first 9 pages. The page 10 looks like this, and I don't want you to worry about it unless you just want to try it. Here's page 10. And if you want to try it, that's fine. Because it says to write it in the simplest form means we are simplifying the radical. But there are a couple of extra things on this page that I'm not going to go into today. You may be able to figure them out just fine if you want to, but work on the first 9 pages of this packet first. And then I'm going to give you about 5 radicals to simplify like we just did. Some simpler ones. And I want you to practice on those, okay? So here's number 1. We will do the square root of 2. Let's do the cubed root. Let's do the square root of the last one is a larger one, and you can use your divisibility rules for it. Now I'm going to give these to you right now, and if you'll stay on for just a little bit, I'm going to give you the answers to make sure you're getting them right. So here are the 5 that I'd like you to practice on. And if you'll get these written down, I'll give you the answers before we log off. Does anybody still need to see them?
I do. I'm almost done.
Okay.
Okay. I'm done.
Anybody else still need them? Brandy, I can't hear you.
I'm good.
Okay, I heard Rachel. Brandy, did you say you're good?
Yeah, I'm good.
Sherry?
Yes, I'm fine.
Okay, you guys start to work on these if you want, and I will work on them and give you the answers real quick before we get off. Okay?
Miss Deborah, I have a question
Yes.
for you.
Sure.
Okay, so when we put our square roots in the calculator,
Yes.
does it matter which square root button we use?
You mean whether you use a square root or the anything root?
Yes.
No, it does not, as long as you tell it a 2 before you do the anything root.
A 2.
So you're telling it it's the square root. You have to tell it what root if you're using the anything root.
Okay. Anything root is the one right up underneath the pi button, right?
Yes, yes. The reason you have a separate one for the square root is only for convenience because we use it so much. Okay, I'm figuring out the answers real quick.
Sorry, after that burger. Well, he'll get over to Mexico or somewhere. You sit around here much longer. Maybe. Margaret, and here in this town. Now that ought to stand for something, July. Well, it does. You're sure up and check what you paid for.
Okay, we've got some background noise going on that's maybe needs to be muted, please.
Miss Bun, I'm gonna get off now.
You have to get off.
Yes, ma'am.
Okay, do you want these first answers? I'm on. I got everything except the last one.
Okay.
Here are answers, y'all, to the first four. Let me know, Lou Annie, when you have them.
I have them.
Okay.
I have the first three, and then
Having
I'll
to go to
look at
work?
the video. Ma'am, I got the first one right. I was confused at first, but then I got the first one. So, you know, me and numbers aren't good friends, but I'm trying. Okay, thank you. I'm gonna get off now.
Okay, I love you. Take care of yourself.
Yes, ma'am. Love you too.
Okay, bye-bye. Okay, here's the last one.
I'm good.
Okay. Be sure and notice that your problems, whether you need groups of 3 or groups of 2, be very, very careful.
Miss Deborah?
Yes,
So, I did my factor tree and I got 3 groups of 2. But I don't know.
3 groups of 2 on which one?
The first one?
You got 2 groups of 2. Here's what I have. Is this the one you're talking about?
Yes.
Oh,
were you
My
started
bad, my bad,
factor-
my bad. You do have 3 groups of 2. I'm so sad, so sorry.
Okay. So I got my 3 groups of 2.
That
But
means you put 2 and a 2 and a 2 on the outside.
Okay.
1 for each group.
Okay. Well,
And
then
the
I have,
leftover, go ahead.
and then I have my leftover 2. He goes inside the house, right?
Yes, he does.
Okay. So the 2s that's on the outside of the house, I multiply them together.
Yes, ma'am.
So 2 times 2 times 2 times 2, 2, 4, 6. No, 2 times 2 is 4. 4 times 2 is 8. 8. And then 2. Okay, so I guess I got it right. Old dogs can learn new tricks.
So you okay?
Yes, ma'am.
Okay, try your 200, but remember it has to be groups of 3 this time. While you all are working those, I'm going to go ahead and turn off my recording, but y'all can stay on.